Okay, this is Florence, the mathematics tutor, and this is our second lesson on differentiation using the first principle. Now, here, with respect to x, we need to find the derivative of f of x is equal to square root of x. Now, let's take our time and break this one down. And from the first principle, this is the formula we use. So here, we can our y is equal to f of x is equal to square root of x. Now from here we need to find f of x plus h. So f of x plus h is going to give us square root of x plus h. That is, we substitute x plus h into x. Now from here we know that f of x plus h minus f of x. So it means that this, for f of x plus h minus f of x, we'll be obtaining square root of x plus h minus square root of x. Now we need to solve this. Now to maintain the originality of this algebra, or what we have here, remember under said we apply what we call conjugate. What we can do is that we can multiply what we have here by its conjugate, but rather in a fractional form. So by square root of x plus h plus root of x over square root of x plus h plus root of x, because this can cancel this and we still have our main expression over here. Now let's see, we can expand. So this multiplies this, and remember, under said, when we are dealing with conjugate, we always obtain difference of two squares. So this will give us difference of two squares. So in multiplying, we are going to have square root of x plus h minus square root of x, by each of them raised to the power 2, over square root of x plus h plus square root of x. So this is what we are going to have. Now remember, the square clears away the square root, because square root is the same as an exponent of 1 over 2. And a number multiplying its reciprocal will always be 1. So we are going to have x plus h minus x over square root of x plus h. But remember, our limit as h approaches 0, plus square root of x. And this is going to give us h over square root of x plus h plus square root of x. Now when we continue, so our dy dx limit as h approaches 0. Now we need to substitute this into the original formula over here. Now we know f of x plus h minus f of x, which is this, all over h. So now this will give us h over this h, multiplying this denominator into brackets, square root of x plus h plus square root of x. Now here, h will cancel h, so we are going to have 1 over there. So we will have 1 over okay, so lim as h approaches 0, 1 over square root of x plus h plus square root of x. But remember, h is approaching 0, so we are going to have lim as h approaches 0, 1 over square root of x plus 0 plus square root of x. And this is going to give us lim. Then we have 1 over Square root of x plus square root of x will give us 2 roots of x. So the derivative of square root of x is going to give us 1 over 2 root x. And this is Florent, the mathematics tutor.